Again, welcome to Mathematical Structure for Computer Science, CS 113, also known as Discrete Mathematics. In these lectures, we will cover the permutations and combinations. So our main objective again is permutations and combinations. And these lectures cover our course textbook, chapter 6, section 3. So first we start with the definition of a permutation. And here we say a permutation of a set of distinct objects is an ordered arrangement of these objects. So an ordered arrangement of R elements of a set is called an R permutation. Now what this means is that if we have a set of 3 items here, 1, 2, 3, and we say we want to permute it in 2, in order of 2, we may have 1, 2, we may also have 2, 1. That's for permutation. Now, if this question is a combination, in combination, if we have 1, 2, and 2, 1, they are the same. The ordered is not important. That's why if we look at the definition here, we say the permutation of a set of distinct objects is an ordered. So that's the key word, an ordered arrangement of these objects. So in permutation, if I have 1, 2, 3, and I want to permute it in 2, or we say 2 permutation, we may have 1, 2, we may have 1, 3. We're also going to have 2, 1, and 3, 1. Then 3, 2, and 2, 3. So the order is very important. But in combination, the order is not important. So if it's combination of 1, 2, 3, and we want to combine in 2 forms, we may have 1, 2, we may have 1, 3, and we may have 2, 3. That's it. Since we have 1, 3, we don't have 3, 1. That's for combination. So combination, the order arrangement is not important. So let's still go through the permutation. So permutation, again, we say the ordered is very important. So we have example here. We have a set S, and set S has a 3 elements, 1, 2, 3. So the order of these elements can be 3, 1, 2, or it can be 2, 1, 3. Now the order arrangement of 3, 2 is called a 2 permutation of S. So for example, we have here, we still have our set 3 elements. We want to do 2 permutations of the set S, 1, 2, 3. So here you can see that we have 1, 2, 1, 3, then 2, 1, 2, 3. But we already have 1, 3, but we still have 3, 1. And we have 2, 3, we still have 3, 2. Because the order is very important. In permutation, the orders, again, of the item is very important. So 1, 2 is not the same as 2, 1. So this is the first example. We want to do 2 permutation of a set that have 3 elements of 1, 2, 3. So the answer will be 1, 2, 1, 3, 2, 1, 2, 3, 3, 1, and 3, 2. So in all, we can say that we have 6 different types of permute, or the permutation. So we have 1, 2, 3, 4, 5, 6. So the permutation P of 3 items, and we are permuting it into 2. So here we will see the formula soon. N will be 3 because those are the number of items we have. And we are going to permute it in R. So R will be 2, like R permutation. So R is 2. In this case, we get 6. So we have the first theorem of permutation. Here we say that if N is a positive integer and also R is an integer that have to be at least 1 or equal to N. So R cannot be greater than N. So again, here we say N is a positive integer, and R should be greater than or equal to 1 and less than or equal to N. So in this case, we may have permutation of N and R. So always N is greater than R, because I cannot have, let's say, 4 items and I want to permute it in 5 perm, no. So always N is greater or at least the same as R. Then when it's the same as R, then we can only do 1 permute, only 1. So if I want to permute P33 and our set was 1, 2, 3, since N is the same as R, we get only 1. The answer will be 1. So here, since R is less than N or equal to N, this will be the result: N times N minus 1 times N minus 2 all the way to N minus R plus 1. That's when we are doing the permute. So our permutation of a set with N distinct elements. Now we can prove this using the product rule. So we can say that the first element can be chosen in N ways. That's our first element. Then the second is N minus 1 ways. And so until there are N minus R minus 1 ways to choose the last element. So we know that the permutation of N and 0 will be 1. If I have 3 elements and I want to, and R is 0 to permute it, and there's only 0, not so, it's 1. Since there's only one way to order 0 elements. So in general, this will be the formula for permutation. Permutation formula is always N factorial divided by N minus R factorial. So in our first question, we saw the P3 and 2, the first example. So N is 3, R is 2. If we plug in the value here, we are going to get the same answer as 6, because we will get 3 factorial. Then this will be 3 minus 2 factorial. So 3 factorial will be 3 times 2 times 1. And 1 factorial is 1. So the final answer will be 3 times 2 times 1, which is 6. So this is the formula we are going to use to find again the permutation of N and R. So here we say solving counting problems by counting the permutations. So the example we have here say, how many ways are there to select first prize winner, second prize winner, and also the third prize winner from 100 different people who have entered the contest. So here we can see that we have 100 people and we want to know how many ways are there to select the first prize winner, second prize winner, third prize winner. So first we have 100 people. The first prize winner, we have possible 100 ways. Now, when we get the first prize winner, the remaining people will be 99. So the second prize winner, we have 99 ways. Then after that, the third prize winner, we take the first and second. So out of the 100, we have 98 now. So the third prize winner will be 98. So you can see that here we are using multiplication rule or the product rule of counting. So in this case, we're going to get 100 times 99 times 88. So the permutation of 103, how many ways we can. So this, and the order is very important, because if James is first and next time James is second, Williams is first, again, there's difference. Let's say the first draw, James is first, Williams is second, and Mary is third. And next time, Mary was first, James is second, William was. It's the same 3 persons that took the position of first prize, second prize, and third prize. But if the person changes, there's a difference. They are not the same. So the best way to solve this problem, product rule. The first price, I have 100 people, so I have 100 ways of getting it. The second price, remaining 99 people, we already taken out the first price, getting out. So we have 99 ways of getting the second price. The third price, we took the second price out also. So we have 98 now, so we have 98 ways. We multiply the 3, we get 970,200. Again, let's try another answer for, for permutation. Here they say, suppose that a saleswoman has to visit 8 different cities. She must begin a trip in a specified city, but she can visit the other 7 cities in any order she wishes. How many possible orders can the saleswoman use when visiting these cities? So again, suppose that the saleswoman has 8 cities to visit, 8 different cities. She must begin a trip in any of the specified city, but she can visit the other 7 in any order she wishes. So now I want to know how many possible orders can the saleswoman use when visiting this city. So first we know is 8 cities. The first city doesn't matter. We start with the first city. So the remaining is 7 now. Now the 7 can be any possible orders. Maybe Chicago first, next time Chicago second, Los Angeles third, next time is 5th, etc. So here the answer will be, 7 factorial. So here the answer again will be 7 factorial, because the first city is already chosen. The rest are ordered arbitrary. Hence, the others are 7 factorial, which will be 7 times 6 times 5 times 4 times 3 times 2 times 1. So we have 5,040 different orders. You can visit the 7 cities. Now, here also we said that if she wants to find a tour with the shortest path that visit all the city, she must consider all the 5,040 paths. And the next question here said, how many permutations of letters A, B, C, D, E, F, G, H contain the string ABC? So here our question trying to say that we have a word here, let's say A, B, C, D, E, F, G, H. And we want to know how many possible permutation of the letters here we have that will contain ABC. So in this case, what we want to do is when we permute these letters, we want to make sure there's ABC in each one. So there's a very quick way to solve this problem. We don't need R here. And we have to count the number of characters. We have 8 characters here. So we have 8. Now we cannot say R is ABC because the question they're asking is, if the question said we have 8 character word and we want to permute it in 3 form or 3 permutation. And in this case, we don't care about ABC. 3 letters can be E, F, G, or G, H, A. It can be any 3 letters. So if that is the case, then 8 will be N and R will be 3. That's if we are permuting the 8 words here into 3 words each. But the questions what that is asking here is that how many permutation of letters we can get that will contain ABC inside. So since we have 8 characters, we can solve this problem by counting the permutation of 6 objects because we take ABC, then we have D, E, F, G, H. So the possible ways will be 6 factorial. The 6 factorial here is telling us that, see, we have D, E, F, G, H, 1, 2, 3, 4, 5, including ABC itself. So it will be 6 different factorial ways we can permute this. And that will give us 720. So next we move to combination. As we said earlier, combination and permutation is almost the same, but the difference is that in combination, the ordered is not important. So we can see from the definition here saying that an R combination of elements of a set is an unordered selection of R element from the set. So this means if I have 1, 2, in combination 1, 2, and 2, 1 is the same. So we just have to take only one. So by in permutation, 1, 2, and 2, 1 are not the same because it's ordered. But with combination, it's unordered. A very good example to use in combination is, let's say we have a company that have 4 staff, Williams, James, Mary, and Joseph. And the company want to know how many possible combination they can get for making 2 shifts out of the 4 employees. So now if we have a Williams and James, it's the same as saying that we have James and Williams, because the same 2 people who are going to work together in the same shift. So that will be in combination, the ordered again is not important. So here we say the number of R combination of a set with n distinct elements is denoted by C and R. Same as we have permutation P and R. So n will be the number of elements, R will be the number of combination we want to make. Also the notation can be NR, which is used and also is called a binomial coefficient. And we will discuss binomial coefficient in section 6.4, which will be our next lectures. So they gave us an example here. If we have S, which is a set, and it has elements A, B, C, D, then ACD can be 3 combinations from S. But ACD is the same as DCA. We can see we have the same 3 elements. The order is not important, but if it's permutation, ACD is different from DCA. But again, combination, the definition said unordered selection. So if I select ACD, it doesn't matter which one comes first, which one comes second. So ACD is the same as DCA, since the order listed does not matter. So let's say we want to find combination of 4 and 2. We have 4 elements, we want to break it into 2s. The answer will be 6, because we have A, B, C, D. We're going to have AB, AC, AD, BC, and BD. Now, if we have CD, we cannot come back to do DC. And if we have BD, we don't do DB. So that will be 6. We have AB, AC, AD, then BC, BD, and the last one will be CD. And I won't start with D, C, and no. The ordered is not important. So the answer will be 6 different combinations. From ABCD, we have AB1, AC2, AD3, BC, then BD, then CD. They are 6 in number. So this is the formula for combination. So normally in combination, we're going to include times R factorial. The R factorial here is what makes it possible for us to remove the ordered list. Remember, in permutation, the formula is n factorial divided by n minus r factorial. With combination, we multiply by r factorial to remove the ordered items that was considered. So for example, if I have A, B, and B, A, I'm using r factorial to remove one of them because the ordered is not important. So let's see an example here. Here they say how many poker hands of 5 cards can be dealt from a standard deck of 52 cards. So let's do the first question first. You can see here we have a total of 52 cards, and we want to know how many poker hands of 5 cards can be dealt. So that will be a combination, because if my 5 cards is, let's say, A, heart, king, heart, king, queen, and jack, heart, jack, queen, altogether is 5. If I have the same hand, but instead of saying A first, we say, let's say, king of the heart first, but it's the same card, and the order is not important. You have the same hand. If you have 5 cards and they are the same, the order is not important. So this question is a combination question. Again, sometimes the questions will be given to us. We have to understand the question, whether it's a combination question or it is a permutation question. But here we are talking about poker hands, playing cards. The order is not important in your hand. So this will be a combination. R will be 5 and N will be 52. So we get C, 52 and 5. So it will be 52 factorial divided by 52 minus 5, which will give us 47 factorial, times R factorial, which will be 5 factorial. So the 47 factorial, we get it because from the formula, we have to say n minus r factorial, which will be 52 minus 5 factorial, and that will give us 47. So since we have 47 here, we can open the 52 factorial up to 48. So we get 52, 51, 50, 49, 48. The next will be 47 factorial. So the 47 factorial at top will cancel the 47 factorial at the down. So it will let it only 5 factorial, and the 5 factorial will give us 5, 4, 3, 2, 1. So we can do some cancellation, multiplication, and later our answer will be 2,598,960. Now let's try the second part. They say also how many ways are there to select 47 cards from a deck of 52. Okay, I'm going to select 47 cards from the deck of 52. So my R will be 47 and my N will be 52. So we have C, 52 and 47, which will give me 52 factorial divided by 47 factorial times 5 factorial. And by multiplication, I can open the top, and same as we did the previous, but you can see that the two are the same. 52, 5, 47, 52, 5, 47. This time, R factorial is 47, but 52 minus 47 also give me 5. So the answer is the same. And here we say, since the order in which the cards are there does not matter, the number of 5 cards at hand is as following. So we have a corollary to, here we say that if N and R are non-negative integers with R less than or equal to N, then we may have C and R which equal to Cn and then N minus R. So we follow the formula C, N and R will give us N factorial over N minus R factorial times R factorial. Now when we do C, N minus R, it will give us N factorial, N minus R factorial, then N minus R factorial. Now when we cancel this, we will see that we will get the same answer or the same formula. So here we are trying to say that if we have CNR is the same as Cn and n minus r. This is what this question also is about. You can see that C52.5 and C52.47, the two give us the same answer. Because 47 here was using n minus r, here is 547. Okay, so let's draw another example here. Here they say how many ways are there to select 5 players from 10-member tennis team to make up a trip to a match at another school. So here we want to select 5 players from 10-member. So straightforward, R will be 5, N will be 10. So we get C 10 5, which we know the formula is what? N factorial over N minus R factorial times R factorial. N minus R factorial will give me 5. 10 minus 5 is 5. And R also is 5. So we get 5 factorial and 5 factorial. At the top, we have 10 factorial. So the answer will be 252. Again, you open the factorials and cancel and multiply. And the next question is a group of 30 people have trained as astronauts to go on the first mission to Mars. How many ways are there to select a crew of 6 people to go on this Mars? So we know the total number of people is 30, and we want to select 6 at a time, and we want to know the possible combination. So again, this will be C, 30, and 6. 30 is our N, and 6 is our R. So we get C, 30, and 6. So the formula is 30 factorial over 6 factorial times 30 minus 6 factorial, which will give us 24 factorial. So we have highest is 24. We can open the 30 factorial up to 24. So we get up to 25 times 24 factorial. The top 24 factorial will cancel the down 24 factorial. 6 factorial will give me 6, 5, 4, 3, 2, 1. So we can do our cancellation and multiplications. And our final answer will be 593,775. So again, the first example here, they say we should select 5 persons from a 10-member tennis team. So 5 will be R and 10 will be N. So we get C 10 5. Then we apply the formula. So the formula is N factorial over N minus R factorial times R factorial. Here also we have a group of 30 people and we want to select 6 out of them. We want to know how many possible combination of 6 out of them we can get. So N is 30, R is 6. So we can see 30 and 6. And the possible combination will be 593,775. So again, this is the conclusion of our lectures on permutation and also combination. So we saw the difference between the two. Again, in permutation, the ordered is important. Combination, the ordered is not important. That's the key difference between the two. We also went through the formula of how to find the number of permutation and also the number of combination. Again, if you have any question, feel free to send an email. And again, wish everybody the best. Thank you.